Okay, now we're going to talk about a first and second derivative of an implicit function. So this is actually kind of interesting because when we find the second derivative, we've got to express it in terms of only x and y. We can't say y prime when we're finding y double prime, for example. But I think it'll make more sense in practice when we actually do this. So this problem actually quite easy when we take the derivative, but the second derivative might be a little bit more challenging. So let's figure that one out. So we're going to do the x treatment again as always. So derivative of xy with respect to x is just going to be y. All right, derivative of negative x with respect to x is going to be negative 1. Derivative of y with respect to x is 0, and the derivative of 6 is 0. So then we go back, and now we do the y treatment. So now we're looking here again, and now with respect to y, the derivative is just x. So plus x, but because we took the derivative of y, we have to say y prime. And now, with respect to y here, well, that's a x. There's no y involved, so we treat that as a constant. So that derivative there is 0. But then we move on, derivative of y with respect to the derivative of y with respect to y, rather, is just y prime because its derivative is just 1. So we just say y prime. All right, now we set it equal to the derivative of 6, which with respect to x or y, doesn't matter. It's 0. So now what we need to do is we need to isolate these y primes here. All right, so what we're going to do is we're going to move anything, all right, that's not y prime to the other side, and then we're going to factor out the y primes from here. So let's take a look and see what that looks like. So first thing I'm going to do is I'm going to write it as x plus 1 times y prime. Why? Because this is xy prime plus y prime. Okay, this right here, this and this, all right, those right there have the y primes. So if you think about it, you distribute back in, you're going to have x y prime plus y prime. So it's just x plus 1 y prime. You factor out the y prime. You set it equal to, suppose you have a positive 1 and a negative y, and it looks just like that. And so now it's really easy to find y prime. Okay, y prime is just going to be 1 minus y all divided by x plus 1, just like that. Okay, and there's nothing to it. We've already found the first derivative. Now we find the second derivative. Okay, so this is the trick though. When you look at this and you want to find the second derivative, you now have a quotient. You're going to have to apply the quotient rule. And I tell my students we talk about high and low. The rule for the quotient, or let me write it out here. The quotient rule. All right, I say low d high minus high d low over low low, just like that. And so now let me write out what high is. So I found the first derivative, now we find the second. High is going to be 1 minus y. Low is going to be x plus 1. And now we find d high and d low. And you'll see it's not that bad. So 1 minus y, the derivative of that is just going to be a negative 1. But then I say y prime. So a negative y prime. But go back. We already know y prime. So I'm just going to say negative of 1 minus y over x plus 1. Just like that. Okay. And then the derivative of low, d low, is just going to be 1 because the derivative of x is just 1 and the derivative of 1 is 0. So now we piece it all together. Okay, so let's see what we get. Low d high is going to be, let's see here. It's going to be x plus 1 times your negative y prime, which is going to be x plus 1 times a negative of 1 minus y all divided by x plus 1, just like that. Okay, low d high minus high d low, which is going to be 1 minus y, just like that, over low, which is just going to be x plus 1 quantity squared. Now you should notice that the x plus 1 here on the left side of the top, x plus 1 cancels or crosses out. So what are we left with? Okay, we're left with a negative 1 plus y. I'm distributing here. All right, and then we distribute that negative as well. A negative 1 plus y. Okay, that's not too bad, is it? Let's double check this real quick. It looks about accurate. Okay, it looks about accurate. All right. So then what do we get? All divided by x plus 1 quantity squared. Okay. So let's see here. When we combine the like terms, what do we get? We get 2y. My pen's acting up. Give me 1 second. We get 2y minus 2, all divided by x plus 1 quantity square. Okay, and it looks something like that. Okay, and this right here should be your y double prime. Okay, your second derivative, and notice we didn't use y prime, we substituted what we knew for y prime. All right, so when we did that, okay, when we did that, we get 2y minus 2 over x plus 1 quantity squared. So we have two derivatives, the first and the second, and notice they're not at all similar. Well, maybe they're a little close, but there's some subtle differences there. Okay, so as always, I hope this video was helpful, and remember, like and subscribe.